Hello, good evening, and welcome to the 7th Better AI Meetup and the very first that we are doing abroad. I'm very glad that we are moving internationally. We started in Bratislava, as you may know, and we are continuing in Brno, so it looks like we are stuck with places that start with Br. I'm really hoping for Brazil. I'll probably be stuck at most with Brussels, so we will see in the future. Nevertheless, I'm very glad that there are so many people here. Just a few organizational questions. When you have any questions to post, please use Slido with a hashtag better_AI. You can post any questions here, and we will stay here until all of the questions are answered. So so just bear that in mind. We are organizing this in as usual with Kinit from Bratislava, Kempelen Institute of Intelligent Technologies, and Innovatrix, biometrics provider. We will have one of the presentation from them, and I would like to really thank Machine Learning Meetups here from Brno for helping us coordinate this with you. And the only thing they asked for in return was to invite you for their next event, which will be held on May the 16th, and it will be about evolution of language models. And we will be talking about language models as well today, and I will immediately start with how the language models that you are currently using came to be, and what are their advantages. And the presenter here will be Honza Černocký, so please welcome him. I'm sure many people know already about him, so just enjoy. Honza, it's yours, please.
Okay, so now my presentation is up. And it's gonna present two revolutions in the single life of a quite senior speech recognition guy. And I would insist on this speech recognition because there are so many things that are happening in general machine learning and NLP and computer vision I'm not aware of. So this will be quite speech centric, and the other questions you might ask I will be probably answering like, definitely. Okay, so let's go ahead and just present you a little bit of my life story. When I was 18, I was planning to be a professional musician or a studio engineer or maybe something in between, and definitely emigrate from Czechoslovakia when I am finished with the university. I'm still doing some music, so that was basically the plan. Then I did this university. Fortunately, Velvet Revolution came, so the point B from the plan was crashed. I was no more forced to leave. And I met speech processing in the 4th year in a year project with Milan Sigmund. Then I managed to go abroad for a diploma thesis in France. I worked on speech with Geneviève Baudouin. And then I had this funny Czech-French PhD studies with not one, but 3 co-directors. So Geneviève, Gérard, and Vladimir were my supervisors, and the topic was speech. Well, actually, I tried to figure out if there is any single neural network in my PhD thesis, and in my own work, there is 0 neural networks. I actually have a chapter in my PhD thesis that we worked together on with Jean Hennebert. That was my colleague. At that time, he was working at EPFL in Switzerland. He used my stuff, these automatically derived segmental speech units, for speaker identification. He had some multi-layer perceptrons in his work, and it didn't work at all. I actually figured out that I never saw any neural networks in any class at the university, and then thought about like the historical context. If you look at the biography of Jan LeCun, this very famous machine learning guy, he was graduating from the same school where I was in France at SIE some 10 years back, and he probably also didn't see any neural networks in any of the classes. And at the time, actually, I had no idea about artificial intelligence, or I didn't think I was doing AI. Then I did a postdoc with Hinek Hermansky in the US, that was 2001. I actually tried to work on some features coming from long spectral trajectories to do better speech recognition. Here, I already had neural networks. So there were some band classifiers and there was a merger. They were multi-layer perceptrons. It didn't work very well. It was actually worse than standard malfrequency coefficients. And I really don't remember if we called it AI or not, but I'm pretty sure that we didn't. So when I came to a conference, it was quite unpleasant because people were smiling at you and telling you, hey, and another guy that believes in this Hinex stuff, right? That's because around 2000 people didn't really much believe in neural networks, and you can even read papers about it. There is the history of the artificial intelligence, and these years were one of these AI or neural network winters. So people were not placing much hope into them. The world was dominated by big Gaussian models, and actually it was quite correct because they were working much better than neural networks. When you worked with them, it was quite tough because you were either writing your own code or using some code that you completely didn't understand, used some obscure hardware like these spared boards. The data was very hard to get. And what was even worse, it was hard to communicate with the others. So, for example, when I joined the Faculty of Information Technology in 2002, there was a group of guys doing computer graphics or computer vision. I didn't understand what they were doing. They used some other boost features. I had no idea. I tried hard to understand, but I couldn't manage. And they didn't understand what we were doing. And we were not understanding what the natural language people were doing, and so on. So there were camps of people that were maybe living in the same corridor, shared offices, but didn't understand each other. So then there was the first revolution. Neural networks that started to dominate the world. We had some little contributions to this revolution. So back in 2007, Franta Gräsel from my lab was working on yet another variant of these trap or temporal patterns, but they started to work. They were actually the first time beating the malfrequency Capstell coefficients. Then around 2010, there was this guy in our lab, now very famous, Tom Mikolov, that he didn't come up with the idea of recurrent neural networks, but he was actually working hard enough and spending enough time and being smart enough to make them work, to make them practically work. And he produced his RNN LM toolkit. He did lots of experiments on the standard data sets. And actually, when he presented this first, people were still laughing like, ha ha ha, this guy is really going to turn the language modeling world upside down, ha ha ha. Then, a little bit later, some people from the big labs and from the big universities were working on it as well. So in 2012, there was this quite important paper by the people from Microsoft, Google, and IBM, showing that we can do even acoustic modeling in speech recognition with neural networks. And the people started to pay attention because they were these people from the big labs, right? So it's not someone from Brno, oh, where is Brno? But if it is Google, Microsoft, and IBM, you pay attention. So that was it, and then basically lots of things happened, but let me think about what allowed this first revolution. I think there were quite some smart people that were working very hard. There was lots of development and sometimes rediscovery of algorithms and lots of engineering tricks to make them work. The data started to be available, and we also stole these GPUs from the gamers and started to use them for scientific computation. There were good things that it brought. So it started to really work and work much better than the systems before. So people started to be aware of systems like Google Translate and Apple Siri and Amazon Alexa because they worked. There were lots of software tools and toolkits, like just think about TensorFlow, Theano, later, a little bit later, PyTorch, that lowered the entry bar, so people with less skills in IT were able to do something. And people also started to massively share the papers, the code, the data, and the models. So now everyone is using Archive and GitHub and Hugging Face. That was not common in the 2010. So that led basically to more trustable and reproducible results, and it also accelerated lots of the research. Well, probably most important, the communities started to talk to each other because people were using same or similar neural networks. So suddenly, vision people managed to understand what these speech guys were doing and so on. And I think that was at this time we started to call it AI, or maybe we didn't resist strong enough when people started to call us doing AI. So, okay, from the 2010 to 2020, I call myself AI researcher, haha. There were also some bad things it brought. Well, the neural networks were much more data hungry, so more data. GPUs costed, of course, more money than standard PCs. So there was a gap opening among the rich companies and the university labs. And of course, the rich companies managed to get lots of the smart people. And what is probably not visible at the first view, the thing that the people were not obliged anymore to do the math and do the programming also meant that some of them just started to connect the black boxes and not think about what they were doing. Okay, lots of post-revolution work. So I think there was lots of development and research on the architectures like recurrent neural nets, attention transformer. You guys know all this much better than I. Training, different techniques, adversarial, reinforced, lots of multimodal stuff where you have some speech, some images, some text. End-to-end training where we started also to retrain the signal processing blocks in one chain, because you can rewrite even a Fourier transform as a neural network layer. Computing, GPUs, tensor machines, supercomputers, edge, whatever, and also lots of new standards and toolkits. So this is just a very shortened list and probably very incomplete just for speech. There were many other things done for NLP, machine translation, and computer vision. So the point was that there was never enough. There still is never enough data from the target domain. So many people, and we too, started to think like how to reuse some data from some bigger pool to do better our task in the target domain. And that was a work that we did between 2012 and 2016 in the IARPA Babel project. Basically, it was Karel Veselý that came up with the idea of the split final layer of neural nets that allowed us to pre-train on many languages and to get a very nice and quality result on a new language that was under-resourced. The other guy that was doing this work and actually repeated it then for newer LSTM models was Marťas Karafiát. Then the second revolution came. Big pre-trained models. I think I don't need to speak about them because you see them everywhere, and you probably know much more of these funny abbreviations that I do. In NLP, there is lots of fuss now about GPT4, ChatGPT. In speech, we have them as well. So there is WAV2VEC, Hubert, WAV-LM, Whisper that can do the whole speech recognition, even some translation. There is computer vision. There is audio, and there are many domains I have no idea about, and all of them are full of really big and very powerful pre-trained models. I wouldn't say it's just a PR hype. There are people, including us, that seriously evaluate the power of these pre-trained models, and they work. They actually work better than anything we have seen so far. So just looking in the speech area, there is the superb benchmark that is evaluating the pre-trained models on a range of speech recognition tasks, and they basically produce much better results than before. So already some time ago I tried to draw some schematics on how is the situation 10 years back and how is the situation now. 10 years back you actually needed quite lots of math, thinking, programming, lots of data, lots of GPUs to come up with some newest and very powerful NN algorithm to have the world's best results. Well, maybe 5 years back, it was similar, the scheme, but you were making use of lots of out-of-domain data and maybe some of the in-domain data, but basically all the rest was pretty much the same, and still all the training and all the development was in your hands. Well, now the situation changed quite dramatically. There is a big pre-trained model that you get from somewhere, some little in-domain data, and this way you have to do it to get the world's best results. So what allowed this revolution number 2? Well, again, smart people figuring out how to train these big models with little supervision or without supervision at all. There is all this masking, quantization, combination of different losses that goes on when you want to train these big models. And of course, it was fueled by big companies having big resources. First, some money to pay all these brave and smart people, more data than you can ever have, and more GPUs than you can ever have. I mean, here the situation really, the scissors opened so much that at a university we really cannot think about training a model that OpenAI or Google has. It's just impossible. They have like so much data that we can never have it, so many GPUs that with our resources we would be training it for maybe 3 years and spend all the faculty budget on just one model. Okay, it brought some good things. It brought good baselines. So I think now if people are doing research, publishing, they really have some strong stuff to compare themselves with. It lowered the bar for newcomers because now you can, as a complete beginner in machine learning, you can download a very powerful model and do some great things with it. I would say this is opening a completely new era for startups because you can get these models and just build the services and products around them. These models have very powerful hidden representations that can be used for many other things than what they were originally trained for. It also got quite some traction of the young people that can say, well, wow, this AI is really something interesting. I'm going to study it and do it for life. And there is a little bit of positive PR. So like, for example, these people that use GPT to write some complaints and then get their washing machine fixed or stuff like this. Some bad things as well. People started to care about the data these big models were trained on. Frankly, when they were used just for recognition, detection, transcription, no one really cared. Once they started generated stuff, like for example text and code, people started to complain, hey, this is my code and there is no headers, there is no license, so we should do something about that. There is even bigger dominance of big companies. There is a feeling that the AI is solved. I heard it like from some people that were in touch with politicians and journalists. These people like see this GPT-3 working and they say, okay, it's done. You can be fired. Like there is nothing more to be done. There is definitely the fact that some people will lose jobs, but maybe this is rather positive than negative because they might do something useful. Let's see a little bit later in my presentation. And some people would be thinking even less. You don't even need to train your model. You just download this big thing, you run it, and it runs. So you just can run it without having any idea what it does. Well, there is lots of negative PR. So the people start trying to delay the development or to ban it at all. Some say that it threatens life, that we will be all killed, and states banning ChatGPT and stuff like this. And I really love this one. I let it without any comments. Big thanks to Alicia Lozano, our friend from Spain, who found it. Like the number and intensity of seeing AI specialists is just enormous. So what can we do? I did some thinking myself. Many other people do some thinking because this is really a new situation for us. There is even a papers. I just picked up a recent one. Many thanks to Katja Igorova from our lab for pointing on it. The paper is actually targeted at academics, but I would say it's pretty relevant also for corporate R&D. So what are the options in this new era? First one is just to give up. On the state level, we can stop supporting AI, turn Czechia into a country of even more assembly plants and storage houses. They are beautiful in the countryside, right? So we could probably have 10 times more of them and it would work. On the personal level, we can do some other jobs, like plumbers are very scarce and they are very well paid. Caregivers in elderly houses, well, we will need it when we grow a little bit older. This is my personal plan. If you are coming from Wallachia or Vsetín, there is a guy running a butchery with exactly the same name, so I'm thinking just going to apply for a job with him. And let's try to think about something positive. So we can actually combine these new things and apply some smart engineering. Actually, that's what we have done. For example, for the last year's Spanish evaluation, we did some combination of Wav2Vec, Caldi, which is a traditional model, and Whisper, and we won the evaluation. We can adapt these models, fine-tune them to tasks that they were not seen or done in the training. So here I have two examples also from our lab. Kartik Baskar has been working on ASR for dysarthritic speech recognition. This is a domain with really very little and very difficult data. And just by taking standard, I guess it was Wav2Vec and some adapter modules, he managed to make it work. We have Juni Peng, our current PhD student, that is playing on taking these big models and just extracting good stuff from them to do speaker recognition. We can work on alternate ways on controlled data. So, for example, the EC is very interested in this because they want to know what the models were trained on. So we have this nice contract with the European Commission together with ELDA in France and TILD in Latvia on some European speech recognition. There is lots of work to be done on fighting bias in datasets and models. We were proposing something in this domain for the Gutscherer/Swiss National Science Foundation. They don't think this is important, so they rejected us. But I think this is a very hot topic. So if there is any industrial sitting that wants to fund it, just talk to me after my presentation, please. We can make things smaller, streaming, real time. So there is lots of techniques to get these big models into real algorithms, real devices. And this will contribute, of course, the production, but also the research, because we'll be able to make faster turnover of experiments. There are some users and some customers that simply never send their data to anything online, like military, law enforcement, intelligence. Similar situation with many government agencies, emergency medical domains. You also really don't want, as developers, to have this hot data in your lab, because then you are messing up with GDPR and you need to have these ethical approvals and stuff like this. So we and many people are trying to do the things adaptable in the wild at the user's side. But you know that users are able to screw up much simpler things than some big pre-trained machine learning models. So there is quite some caution. It's actually funny that even some funding agencies woke up, and this is a recent call by EDF, the European Defense Fund, that wants to do something like that, adaptable by users, and even wants to run a challenge on it. You can expand to domains people never thought about would be usable, but you have to be careful because some people are faster than you. So for example, there is this AlphaFold by DeepMind that is using transformers to predict the folding of DNA structures. And there are other companies in DataMole, that is Czech, that does some really nice things in agriculture, and like well-being and productivity of animals. And actually some of us will have to work with politicians and with lawyers because there is lots of stuff happening, and we definitely need to do some societal good, but also be careful that we are not becoming this skanzen and just buying all the technology from China and the US. And actually some lawyers and politicians are really smart guys. So if you want to at least virtually meet one such a smart guy, there is Radim Polčák at Masaryk University, and there is his presentation for AI Czechia that is available online. So I think we need more technical people to speak up, to outweigh all these ogists and offists in the government and the EC offices. And finally, there is the education, because I think we should tell the youngsters that AI, and by the way, any other technology is a good thing to do, that you don't need to be from a rich family, you just need very limited resources to start. If you like math, you will see lots of math in action, and I would say AI is very inclusive, so you can travel, you don't need to overcome some administrative and political obstacles like lawyers or doctors have. There is lots of opportunities for girls, for under-resourced and disadvantaged groups, and also for some multicultural environments. This is, for example, like the flags in my lab. There are, if I count well, 10 nationalities for the moment, and we are just in Brno. It's happening right here. So just to conclude, I think there is no time to retire in machine learning. It's rather like this. And that's the end of my presentation. Thank you very much.
Thank you, Honza. Thank you very much for your presentation. I have to say, I'm quite glad that we have moved from the times of hermetic teams working alone in their basements on some not well understood models. So that's why we are here, because we are not hermetics anymore. And I would just like to remind you that you can still post questions to Honza or to Jakub, who's coming next, on hashtag better_AI at slido.com, and we will answer all the questions at the end. And since we are talking about models, not only speech models, but all the others, Jakub from R&D, he's the head of R&D at Innovatrix. He will show you how to actually compare those models when you and how to make benchmarks, and and he's doing a lot of R&D here in Brno. So pay him a visit if you are interested. And for us in Bratislava, we usually thank him a lot for his work, because he's providing us with biometric algorithms, and we usually call them not the R&D guys, but the guys with the best gaming machines, because they use all the GPUs that Honza mentioned as well. So Jakub, it's yours.
So thank you for the kind introduction. And
yeah,
I'll start with a story. Imagine that you want to organize an election, And obviously, you want the elections to be fair and democratic. And one of the big part of that, of the fairness, is that you want to allow one person to vote only once, because if one person would vote multiple times, it wouldn't be that good. But you might live in a country that doesn't have passports or IDs or any way how to basically identify the citizens in a reliable way. So how you want to prevent them from voting multiple times? You can't recognize them, and this person could vote in this village, in this city, in this village, in this village. Basically, it would be just on the distance of all the election committees that around the country. So you could manage multiple of them. One of the possible solutions is biometrics. Basically, you could pre-register all the citizens. You would take their fingerprints, for example, and then you would, on the background, deduplicate all of them, and basically you would hand out registration cards, and you would invalidate some of them if you would find out that someone tried to register multiple times. So this is a possible solution that works. We actually did this, and so this is one of the possible solutions. So if you decide to go with this solution, you might think, okay, but I need to buy this system. We as a government don't have it, and there are multiple vendors. So you go online and you find multiple vendors that you can buy this from, and you say, okay, so I need to basically make some decision from which vendor I want to buy it, and there are also variables: speed, price. But you then realize that accuracy of the system is actually one of the most important important metric in the decision process, because you need to have some manual verification. All the machine learning system, they have some error rate. No machine learning system is perfect. You can't find that. So, and these error rates you will have to manually verify. You will have to have basically some person that will check that is it the same guy or not. So that can be time consuming. So you want basically the most accurate system that you can get your hands on. So you go to the websites of the vendors, and you find different accuracies for that. Let's not go into what the accuracy means right now. Let's say that lower is better. And you say, okay, they have different accuracies, and you think, okay, I'll go with the vendor C since it's the lowest error rate. So okay, I'll go with that. But then you think about that, and you realize that this is not that easy, because they might have evaluated on a different evaluation set. And in our experience, that matters a lot. We had one evaluation where basically the 10-print fingerprint recognition, where you search with all the 10 fingerprints on the data set, it was basically solved. The error rate was 0.0 or something. So that was fine. But then we had a different data set where the same system had error rates around 5%. And as you can notice, the 0 and 5% is a bigger difference than all these error rates here. So the evaluation set matters a lot. So you think, what can I do about that? One of the possible solutions is to get some proof of concepts from the vendors and run your evaluation in-house. That is feasible, and companies actually do that. But there are some gotchas about that. For that, you actually need to have some evaluation set that with reliable ground truth that you trust. Because without that, the evaluation is just meaningless, and basically you need to have the evaluation set. You might not have your own. The governments usually don't have that. They have some registries, but sometimes it's a mess. And so you say, okay, I don't have any of my own, but maybe there is something publicly available. And you go online, and for example, for the fingerprints, you will not find anything useful, basically. But even if it would be a different domain, it might not be available, it might be way too small, or something like that. So, yeah, that's the publicly available datasets will also not work. And even if you would found a publicly available data set large enough that you can use for the evaluation, you don't know on what data the vendor trained the model, because right now it's all machine learning and there are the models, and the vendors most likely will not tell you what exactly data they trained it on, because it's part of their trade secret, and you really don't want to evaluate something on an evaluation set that one of the companies trained on, because it would be just nonsense. And so there is that. And even if you would basically found some evaluation, some public available data set that has a forwarding train test eval, you can't trust that the company didn't train on the eval set, because maybe they have their own evaluation set and they just buy this data set and they train on everything. That's possible, and it doesn't violate anything. So to summarize that, the vendors are not directly comparable by the accuracies that they claim that they have, because even if you trust it, the evaluation set might be different, which basically invalidates everything. And in-house evaluation might not be feasible, so because of the reasons I've talked about. So what is a way how to basically compare the multiple different vendors? One of the possible solutions is that there is a benchmark that is managed by a third party that you trust, that is independent. If the third party would be affiliated to some of the vendors, it wouldn't be very reliable data set, very reliable benchmark, because you don't know whether they don't share some of the data or something like that. And ideally, you also want that the data set is not that the data set that the benchmark is evaluated on is not publicly available at all. Even you most likely don't even want the images itself, if it's fingerprints or faces or something like that, to be publicly available. Because, for example, we have participated some challenge at some conference, and they provided us with evaluation set, and we were supposed to detect something or something like that. And then so we did that, and we trained some models on some other data, and when we were at the conference, we found out that some of the groups, they actually took part of the data set, annotated it manually, and they trained on the evaluation set. So I wouldn't want this evaluation set in the benchmark to be publicly available, to be sure that the companies they don't actually are able to manually annotate it, because it's possible to do that with some pre-selection and then manual verification. So that's possible. So ideally, no publicly available images or the raw data. One of such institutions is NIST, that runs actually quite a lot of benchmarks. Honza Czernotsky, they actually participated in the speaker recognition, and there is multiple of them. I'm not sure how many of them. They also run iris recognition, iris identification benchmarks. They have multiple face-related benchmarks, like face identification, face anti-spoofing detection, basically where you are supposed to tell whether it's on a camera whether it's a spoof or not, whether it's a basically printout of a paper with a face. And they have multiple fingerprint benchmarks that you can participate in. This is obviously not the only institution available. There are some others. I know Common Objects in Context, which is from Microsoft, and then there is Computer Vision benchmark, but there was also the super benchmark that Honza mentioned. So it's not like it's the only one, but for us as a biometric company, it's the most important one, the NIST one. So as a summary from the BIOS perspective, in this election scenario, we could just go and check online and check relevant benchmark. For us, it would be fingerprints, and check what is the best algorithm there, how they score, how the error rates are different, and incorporate this into our decision making process. Obviously, the accuracy is never the only important metric. It might be speed. It might be how much memory does it need, and so on. So, as a summary, if you want to buy some machine learning algorithm, check whether there's a benchmark or not. So far, I've talked about the perspective of a buyer of the algorithm. But here, I guess that most of you actually make the machine learning algorithms. So what are the reasons that you might want to participate in a benchmark? So for one, it's that you might be able to separate yourself from the competition. If you do good, if you do well in the benchmark, then the customers will see it, and it might be good for your sales. If you are lucky enough or good enough, sometimes both, you might actually win it, and you might be able to claim that you have the best fingerprint recognition algorithm or something like that. And finally, some of the algorithms they need some certification. For example, with fingerprints, there is Minix benchmark where basically everyone submits because it's necessary for the algorithm to be certified. And so you basically need to have that. It's a no-go without the certification. As I mentioned, we have some experience with the NIST benchmarks. We participated in multiple fingerprint benchmarks, basically all three of them. The LFTF, the last one, and they are all related to fingerprints in different ways. Then there is a face identification benchmark, and there is this anti-spoofing benchmark, and there is also iris recognition benchmark where you are supposed to identify people by their irises. And to give you an idea how this whole process of submitting something to NIST works, in some other benchmarks it would be probably similar. You need to code a solution. You need to have that solution. You then run some validation that they provide you. That's actually quite nice because you are able to check most of the check marks right away without sending it to them. Then you submit them. Then most likely they will give it back to you that they found some problem with it. So you iterate on that. Then finally they are okay with it, and you receive a report, and it's online on the website, so you can see the table, how good you did, and so on. And then you need to wait 3 months. Sometimes that's a bit annoying because you have a solution that you just want to send, but there is a 90 days cooldown period when you cannot submit. And in some of the benchmarks, it's now 4 months. So that's even more annoying. And it basically limits how many submissions you can make in a year. So yeah. But I understand that because they have also limited hardware, so it's not like they can run everything. And then you repeat. And the repeat part is quite important because, for example, in the face identification benchmark, the competition is really, there is a lot of competition basically. And in a year, you can drop like 80 places. The competition is there, it's insane. And if you want to stay on the top, you need to repeat, you need to submit quite often with always some improvements in the algorithm. As I mentioned, we actually participated in quite a lot of them, and we actually are first in some of them. And so now we know that we have the best fingerprint recognition algorithm in the world, or the best iris recognition algorithm in the world. So we don't need to come up with some marketing arguments. We just can point them to the benchmark site and say, hey, look, we know that we are the best. So to conclude my talk, and this the take-home message that I want you to go home with is to participate in benchmarks if you can. If you are in a domain where you can and there is a relevant benchmark, do that. And that's everything from me.
Thank you.
Thank you.
Thank you, Jakub. Thank you very much for actually teaching me something new about my own company. Yeah, we actually do need some more marketing claims as well, because otherwise we wouldn't have any work. But thank you for doing the hard part for us. Now we will have a short jingle, and right after the jingle we will get to the Q&A. So looking forward to that. Thank you for staying with us and for posting your questions. We will go through all of them, hopefully. So even if you have some questions now, so don't forget to post them here. We are not using microphone because it takes some time. So I will get to the. We will probably start with Honza, I think, because the first of the question is, what is currently the best tool for speech to text for Czech language?
That's
yours.
Nice question. Thank you. I have no, not that I would have no idea, but I don't know exactly. It depends on the purpose you want to use it for. So definitely, if you want to do some security defense, you would buy something from Phonexia. If you are into dictation or some news analysis, it would come from Newton Media. You can actually get this whisper model and try something. It does something reasonable for Czech. So what is currently the best? I don't know. You can try superlectures.com or spokendata.com. There is some model that you can test. It depends heavily on the domain, on the conditions. Sorry, not to be able to give better answer.
Thank you. It's actually quite a lot, given the language. So, what are some viable approaches to solve the challenges of smaller languages? You mentioned both of you quite a lot that that we have smaller datasets. So, how to solve the challenges of smaller languages and smaller datasets as a whole? Generate more data, perhaps.
Yeah, you can get just these big pre-trained models that can do already many things, but generally there is no magic solution. If you have a language with really small resources, it will never be, well, it will always do something, but it will never be of such a good quality as what you can get for English or Chinese or just these languages with virtually unlimited data and money and human resources.
Mm-hmm. Thank you. Jakub, do you have something to add?
No, I just agree there is no magic solution. It's just...
Okay, now we have the learner question. What tools and resources do you recommend for beginners to start learning how to use or work with pre-trained models in a multidisciplinary approach? I think, Honza, you mentioned that it's now much easier to actually work with AI because it's much more, let's say, available.
I should ask some of my colleagues and students that are doing the real work and not management and presentations like this. Well, I would just say go to Hugging Face and try to get one of them and documentation to it and install it and run it. That's probably the best start, and then we can start looking into the theory.
For vision, there is also the Hugging Face, and there are some other hubs, and there is also TIM package that we use heavily, with pre-trained models.
Okay. Speech recognition again for Honza. As the speech recognition is close to being solved for practical purposes, what do you? There's some agent provocateur here. What do you think are the next endeavors for speech recognition research community?
Okay, I think it's to solve ASR in practical scenarios that are not the general ones as dictation or in-car recognition, where it is really close to be solved. I mean, you have really lots of these small languages, really difficult domains like noise, reverberation, bad communication channels. And there is also lots to be done on the combination of speech just with the follow-up modules, because speech recognition itself is not very useful, right? You want to have speech machine translation or maybe speech summarization, and you can work on these modules alone, but it's always much better and much more fun to try some end-to-end training. So I think it's not solved.
Yeah, so don't worry, if you study speech recognition, you will be useful even in 10 years.
Yeah, you can also always go to do the butcher work or maybe switch to something else that is
for me, when I use Google Meet, there is this real-time closed captions that's far from perfect.
Yeah. Especially in other languages than English. Yeah.
Even in English, it's not perfect. And if you say some foreign name, it just doesn't work.
Yeah, that's right. Or if you have a very strange accent, then, it's but it's always fun to read them, actually, I have to say. So maybe don't change them too much. How to measure a goodness of a representation or embedding produced by large models? And that's maybe a question for both of you.
For us, it's the performance on a downstream task, basically what we want to use it to. That's, that.
I would say the same. Just pick a target task or many target tasks and evaluate the model. That's what people in this Superb challenge are doing, and I can hardly figure out anything. Well, it would be super to have some magic way of evaluating the quality of representations. Maybe you can try some clustering, but still I think you want to use it in some target task. So that's it.
Okay, thank you. And now the million-dollar question. Do you think that ChatGPT and similar is really intelligent, or is it just a giant language model?
I played with it and I don't think it's really intelligent. I think it's able to produce very smart responses, but I wouldn't say it's intelligent.
Yeah, it sounds like that, actually. Yeah, but I think it acts very persuasively if you are used to the maybe older language models. But yeah, it's really far from intelligent.
It can very well produce like repeated and general content. That's why the politicians like it so much.
Yeah, I tried probably all of the versions of ChatGPT to write an out-of-office reply, and it still doesn't work.
Are there types of algorithms that would be difficult to benchmark and compare, and what would they be? It's again a question probably for both of you, if you can think about it. If not, just saying not sure is still fine.
Well, I think it's anything that is really connected to what the humans find difficult, which is evaluating creativity, harmonies, like inspiration, beauty. I don't know. I can, and it's so personal that we can take 10 people and discuss what is the best music, and we will actually end up in a quarrel. So I can, if people cannot agree on what is a good music, and I hope they will never agree. We can actually evaluate music beauty.
That's right, actually.
I would just add probably something that's very dynamic in a nature that basically if you run some evaluation and then it changes the world and then you can't run it again because you are in a different state. So probably something like that.
Okay, thank you. Now we have a question that's probably more for Jakub. How to distinguish between the live finger and an image of the fingerprint, which is basically like a presentation attack with fingers?
It's best to do it directly in the sensor. We don't actually try to address this right now. We rely on the sensors themselves, but there are some responses from the sensor that you can use. I'm no expert in that, to be honest.
Yeah, but there are ways, and some fingerprint sensors actually do those. Mostly those that are used in security. For example, they measure like blood flow, and they use infrared light to detect maybe liveness and so on. So, yeah, it can be done. It's usually not embedded in your phone, but it can be done. Just a sec. Biometrics always comes with ethical challenges. How do you manage these when benchmarking your algorithms? Do you leave it to third parties? This is most probably pertaining to data sets, I would say. The ethical challenges when you benchmark, and I would say data sets, bias, and so on.
Okay. Well, for example, one of the benchmarks, they actually measure bias in the algorithms, in the face recognition algorithms, but surprisingly there is quite a lot of bias also in the iris recognition algorithm. It's not unique to some algorithms. I checked some of the top performing ones and they had the same bias. So in the biases you just need to try to train uniformly on all the genders, all the races and so on, but it's never perfect, to be honest.
I would just add that it's often never up to us researchers and developers, because we are very often given some data and then like here is the data and do whatever you can on it. So do like aim for the best performance of on the target task, and at the same time figure out like if there are any biases. That this is very complicated task.
And it's also hard to annotate all the biases and get a reliable set for all the combination of all the genders, races, ages, and so on. So it's not like it's a closed solved.
Yeah, and also there's often problems that, as both Honza and Jakub mentioned, that you don't in many use cases you don't have like really enough data or too much data, so you are just stuck with what you get. So that's also a problem. But you know, it can be measured at least. And this one is for Jakub. Do the benchmark submissions cost money, and if so, how much?
They don't accept one, but it costs $500, and you just get some registration of your biometric company, and that's for life basically. We have it, I don't know, for 15 years this registration, and from then we just use the same ID and that's it. So almost none of them cost anything, but this one costs $500.
Okay, thank you. And now this is probably not from the guy that was asking about ethics. I need my voice clone. What are the best tools? Is it 11 Labs, Play.ht, or any open source that would sit on my computer? So please help this guy.
Yeah, I'm sorry, I'm not gonna help. Not because I wouldn't like to help, but I haven't played with this with all these tools, so it would be up to to the person who asked the question to find out. What I just know is that the availability and the quality of these tools like progresses very fast over the time, and I'm actually not so afraid of singularity of AI and like what Elon Musk says that it will kill us all, but I'm really afraid of the deepfakes in the voice domain, in the video domain, because they are going to get so good, and well, we are probably prepared for them, like as relatively young guys who are technologically savvy, but most of the population is not prepared to. Most of the population is ready to delete fake emails and like toss the fake letters into the rubbish and so on. But if someone just calls you with the voice of your relative and asks for something, that will be very hard.
Oh yeah.
But the last Czech presidential campaign showed that you don't even need deep fakes. You just can cut the video correctly, and that's enough. There was some talk, and
yeah, you don't need too smart artificial intelligence to fool
yeah.
normal people. So, is there? And this question is actually not anonymous. So, thank you, Lukáš. Is there a significant effort being made to lower the neural network's hunger for data, making models more accurate and trainable with less data? And who is leading the effort? Do you see any such efforts?
I don't know who is really leading these efforts, but yes, there are efforts. There is, for example, the work that Kartik made, but he didn't invent, like, there are these adapter modules that you can insert and sneak into your big model to adapt on really little data. And frankly, I don't know who was the first author, but there are many efforts in this direction. Of course, people would like to train on little data.
Yeah.
I have nothing to add, to be honest.
Okay. We have a question that's probably more for Honza, but I think Jakub can chime in as well. Is there a way to distinguish between live voice and synthetic generated voice? And more, maybe more broadly, how do we even do like similar judgments for faces or fingerprints?
Well, very, very difficult, and it will get even more difficult because the people that are just that want to create the deepfakes can just use these detectors and plug them in some adversarial training, and well, they will always have the edge. I would say I'm afraid of.
Yeah, I agree, but it's always that the deepfakes get better, but also the recognition gets better, and it's sort of a never-ending challenge.
Yeah, it's like the antivirus software, you know. Once you start detecting everything, people will come up with new ideas how to fool those. So that's that's why it's useful to learn it, because there will always be guys who will be against you, so you can choose the sides even. We have a student from Department of Multimedia Technologies from Košice. Do you work with Slovak datasets as well? That's for Honza. And do you dispose any datasets?
Currently no, because we have no project where we would really need Slovak. We have access to Czech to Slovak speech data, which is quite an old dataset. From the year 99 or 2000. I'm sorry we cannot share it because we are not the owners of it, but if there is any student that wants to do some cooperation, I think we can talk about it.
Yeah, so probably write directly to Honza and he will try to help you if it's possible.
But it's not newest and not biggest data, but at least something that could be used.
Okay, and again, for Honza, which era of the artificial speech recognition evolution did you like the most in your research, and why? From all the ones that you mentioned.
I don't know. Well, I like the era when I was myself doing experiments and wrote some code and was running and checking the results. But I also like the current era where I'm like the supervisor, like the ugly manager, and I just try to follow all these new things. I cannot really tell which era was or is the best.
Yeah,
I like them all.
I would like to summarize that it's been fun and it's still fun. So yeah, it's
I'm a happy
something
man.
it's something to pursue as well. Is there a hidden layer representation that is universal? And I'm not really sure for whom this question is, but anybody can pick.
I'm not sure universal for what? Like for different modalities or?
No, not sure.
But we don't know. Okay. For different modalities, I would say no, to be honest. In theory, you can use the vision model for vision if you if you render the the spectrogram, but I'm not sure how well that would work. Probably not that much.
What was the question?
Is there a hidden
universal?
Yeah.
I would say some of the new like unsupervised trained models that are just into this masking and quantization, they come with some universality or generalization. So, for example, we see it with the speech models that can be used for many of the tasks, and they perform well. But I cannot, if universality means that I take a speech model and I'm going to recognize like molecules in some chemical substance, then probably not.
Yeah, thank you. Honza, how to properly evaluate pre-trained models like Whisper that may produce different outputs or transcripts for the same acoustic input?
I wouldn't say they should produce different transcripts for the same acoustic input, but well, I would just say it should be evaluated exactly the same as any other ASR, comparing the output with reference transcription and computing the deletions, insertions, substitutions, and computing the word error rate or any other classical speech metric.
Okay, thank you. Now we have a quick question that's for me, actually. Thank you. I think this is the first time that I can answer better than our guests. So, is it possible to watch older episodes somewhere online? Yes, we have a YouTube channel that's Better AI Meetup. Go there. There are all the episodes from the start, and this one will be there as well. Hopefully tomorrow. So, yes, thank you. This is probably the first and the only question I will ever get, but never mind. Do you think that it would be good to start learning neuroscience to better understand and communicate with generative models, or train them differently? This is actually presuming probably that AI is somewhere close to human brain.
I'm not sure about neuroscience, but sometimes it happens that if someone comes from a different field, they have different experience, they do something differently, and they basically realize that they can use that in the machine learning world. I'm not sure about neuroscience. Mm-hmm. I've never really bought into that neuron in the neural network.
I would say something similar. For example, our great guru Hinek Ermansky always has this parallel with the birds and with the airplanes, saying that we have taken some basic principles from the birds, but we are not trying to mimic all the feathers and all the wing movement, and just construct airplanes that perform well and fly, carry passengers or weapons. So, yeah, not sure.
Mm-hmm. There's a question about tech stack. What tech stack do you use in your company and at the university?
What text?
Tech stack. Which what set of technologies? Sorry, the questions are here as well. So if I don't read them correctly, you can just check.
Okay, so we use mostly PyTorch. We use Python. We integrate almost everything into C++ because we deliver it in different platforms. And then the end products, there are many of them, and to be honest, we use their Java, Rust, and C#, and also, yeah, a lot of them. And we are starting migration to Kubernetes right now. So,
in my lab, we use a horrible mess of all possible toolkits. Tools, scripting languages. Most of them would be now used based on Python, so there would be like PyTorch maybe, but also SpeechBrain, Chainer, ESP.NET, and gluing with Python with shell scripts is just quite a terrible mess. We are an academic research laboratory. If we have to deliver something, it's a pain.
Yeah, I think if you are a pioneer in something, it usually ends up that it's glued together somehow.
Yes.
Nobody really touches it, so it doesn't fall apart. So, Okay. This is again for Honza. Are there some specific challenges for automated speech recognition for people with speech impairments like lisps or stuttering?
Well, I just don't understand completely if challenges mean like some kind of evaluations or some problems. So
probably for speech recognition.
Yeah. So for the like evaluations or some competitions, I have heard of none. This is a very small domain, but there are actually many like technical problems or challenges. The first is, of course, the availability of data, because normally we measure our data in hundreds of hours, and Facebook and Google would measure them in thousands of hours, while for these impaired voices we can have maybe hours or even less. But still, some stuff can be done, as for example was done by Kartik Bhaskar. So if you want to know some details about it, just go to our webpage and check for Kartik Bhaskar's paper, I think last year at Interspeech. There.
Okay. We have a question that we partially answered before. So is it possible to detect the deepfake, which basically means, some sort of presentation attack, as we call it?
Yes, but it depends on what accuracy you need.
It is, and it will become even more difficult.
Yeah, it's like that circle all over again. That as deep fakers get better, we get better as well, and it's a never-ending story. Now we have 3 sets of learning questions, thanks to Mohamed Tekaya and an anonymous person. So, what projects and tools would you suggest for a beginner to begin his learning in the field of AI? What skills, and maybe how to find resources? I'm sure you work with a lot of papers as well. So where would you start, or where did you start actually? Maybe.
I started on some traffic surveillance, which was quite fun. But for me, basically, it's to find something that you are interested in, something that you wouldn't do just for the learning, but you actually want something out of that. And skills, well, for me, math was also always quite important, but I understand that it might not be for everyone. But I really suggested to learn how the neural network actually works, why is it trained, how does the gradient propagate, and so on.
I will maybe just recommend 2 parallel paths. The first is just to get any model, any recipe, any data, and just run it, just to see that it works and that you can really touch it even on your computer. And at the same time, maybe check some machine learning courses. So I don't really see everything they have on Coursera or MIT, but at FIT there is the SUR class that has been done by Lukáš Burget for many years, and we have like public recordings and public slides. There is the NeuroNet course done by Misha Hradiš. So I think if you take these 2 to start, and if you find some mathematical concepts that you don't understand, you should go back to math. And as Kuba said, math would be quite a basis if you really want to understand what's going on.
And there is also a summer school in Košice that we are sponsoring. It will be 1 week, I think, but you know probably more about that.
Yeah, there's DeepMind, the Google researchers will be stopping by, so there's also something to visit as well. But I know they are doing courses in lots of places. So yes, Košice is one of them during summer, but you will find them in many different places. Now we have a question about reducing the error rate of artificial intelligence algorithm dedicated for supervised learning. How to reduce it when you do supervised learning?
I'm not sure I understand the question.
I don't know. Like usual ways, more data, better model, bigger model, train it for a longer time.
Yeah.
Better loss function.
Yeah. So and some, in our experience, quite interesting is use some auxiliary loss functions basically to enforce some knowledge that you have into the model.
Yeah. And actually, how to select the artificial intelligence algorithm to deploy which best match the use cases model for in specifications. I guess the best would be just to resort to benchmarks and ask what are you looking for, speed, accuracy. There's some use cases that need like memory footprint and so on.
Yeah, I think if you are into the standard use cases like biometrics or speech recognition that are quite established tasks, then you can look into the benchmarks and papers and challenges. The thing is becoming complicated when it is something new. So I guess that the guys, for example, from DataMold, when they try to develop some algorithms for milking the cows, they didn't have any benchmark to start with. So that must be some clever engineering guesses and trial and error, and I hope the animals didn't suffer much.
But there is also the aspect that at the beginning you have some business requirements or some requirements in general that you want to satisfy. You hardly ever do some machine learning just for the fun. You usually have something that you want to solve, the problem that you need to solve, and for example, the timing is relevant. If you want, it might be very different if you want to do online speech recognition, or you can process it offline, 2 times slower than the actual speech is, and so on. I'm making up these 2 times smaller, 2 times slower. So.
We have some questions regarding ChatGPT, so I would just remind you that we don't really have guys that are, that deep in ChatGPT, although I guess they are using it for fun. What do you think? Is it a real problem that large language models hallucinate, or that we don't actually understand what the signal in the data neural networks are following? So basically the black box questions. And is it possible to solve this?
I saw a paper from Google where they tried to solve this hallucination by providing a reference where you can go to check the source. I haven't read it. I just saw the abstract, and I find it a bit problematic. I try to use ChatGPT as a tool for programming, basically where I ask it questions, for example, to generate some graphs, and sometimes it gives an incorrect answer that would be nice if it would work, because it was really cool API design, but it didn't work. So yeah.
Similarly, I think there is quite some work running on the grounded models that would support you the answers with references to some documents. And also I would say that as any new tasks, some people regard it as an ultimate solution. Okay, we are gonna trust everything that this ChatGPT tells. I think we would need to, and Czech people are quite good at it, they just don't believe anything. So I think it's good to use some of our critical skills just to wait what we can get from these models and whatnot.
And I would say this is maybe a question from one of your students, Honza. Can we use ChatGPT to prepare for IELTS exam?
I don't know what is IELTS.
Yeah, that's probably the language as a foreign language, something like that. So that's to upgrade their English level. Yeah, it's.
I don't know how the test is run. If you can write an essay at home, and in the past you could ask your uncle that is speaking better English than you to write the essay for you, or pay someone, and then now you have ChatGPT. Okay, then you can do it with ChatGPT. If these guys think it will help them for the current use of language where you have to react to people and to converse, I would really need to see what is the point.
Yeah, but the short point is don't do it. It's cheating. So.
Well, you use ChatGPT as any other tools you can get, but use them in a
Yes.
legitimate way.
Yes, and what is your opinion in using ChatGPT for academic papers?
Well, they can do quite a good job for you. Maybe not writing the paper, but checking if it is written in correct English and if the structure of the sentences is like reasonable. And it can. I heard. I never used it. I'm sorry, but it can do a reasonable job for you. Then, if you are reviewing papers, there is always this like ranking of novelty. So I wouldn't say ChatGPT would help you in writing anything new. But maybe I'm just too focused on a domain where we have some hard results and hard benchmark. Maybe if you are in some other domain where a good work means just a good compilation of something that has been already written, then ChatGPT or any other big language model can probably do very decent work for you.
Okay, there has been talk about maths from both of you. So, what math subjects would a student need for your application besides statistics and discrete math?
This chain rule and so on, and
Linear algebra.
yeah. If you want to work with GANs, you need some knowledge of game theory. Probably it's basic, but some.
I wouldn't say the math we need for machine learning is so complicated.
It was before. I remember when I joined the PhD, you used some I vectors, and I was really scared of them. So we don't need that anymore.
Okay, and since both of you are either out of school or even in academia, do you consider a master's degree in AI to be valuable and intelligent? It's from a guy who finished bachelor's in computer engineering.
I would have probably studied that if I could have at that time.
I would say it depends on when I see our masters. What do you want to do? Probably if you just want to understand the basics and play with the blocks and connect them, then bachelor or even high school is good. If you want to go a little bit deeper, understand the math, how all these things were built, then I think it's good to get a master's.
Yeah, and this is probably the last big question for AI. Are you aware that what is the progress in deploying generative models to larger tasks, which means, for example, from generating images to like generating 3D environments?
No idea.
I don't know.
Yeah, they know a lot, but they don't know everything. So. Yeah, so
I should know.
It's something that we actually plan to introduce in next meetups as well. So just stay tuned. So that's the answer to the very last questions. What are some other events except this meetup? Next meetups. For today, I really would like to thank Honza and Jakub for staying with us and answering all your questions. I thank you for posting a really lot of questions. I think we broke the record today. So very glad that you've attended. We will see each other in Bratislava or hopefully in Brazil in June. In Brno as well, yeah. Brno, Brazzaville, everywhere. Everywhere they will host us like the guys from the MLMU here. We will be gladly attending. So thank Kinit and Innovatrix and MLMU for making this happen. And we will be seeing each other in June. And yeah, this is everything. Goodbye and good night.
Thank you.